Welcome everybody to this installment of our LiveWire event. This week we're going to be looking at how robocalls have been a constant nuisance in the industry, are getting worse as the time passes because of many different tools that are coming into the market, and how those can be prevented through a couple mechanisms. And in particular, we'll look at one interesting way of using voice as a way to identify a robocaller as opposed to a live caller. So today's LiveWire about. We'll go through a few things. We'll look at what robocalling actually is for the few people that haven't had the pleasure of meeting a robocaller. We'll look at how to stop robocalls using the various industry efforts and the application level things we can do to stop them. We'll look at our application, which is a voice CAPTCHA relay app that uses a CAPTCHA to filter calls. And then we'll try to call and fake being a scammer and fake being a legitimate caller. We'll take a look at the code, and there's a 10 minutes, there's a 1 minute survey at the end that oddly takes 5 minutes on the schedule. Of course, people always notice that, and we'll have time for questions at the end. Great. So, well, my name is Luca Pradovera. I'm the lead technical evangelist at SignalWire, and I've been working in the space for about 15 years, probably a little bit more at this point. And I've joined SignalWire since the early days, and it's been a great ride. So stay tuned because we have even better things coming. Also, I generally don't wear a tie. So, what is robocalling? Robocalling, or automated calling, is the practice of making automated calls to deliver pre-recorded messages. That is, when your phone rings and you hear a recorded voice saying something, it doesn't necessarily have to be technically pre-recorded. It could be text-to-speech. So we can broaden that definition to say it's any call you receive that doesn't have a human on the other end. They're mostly used by debt collection agencies, political agencies of various kinds, and a lot of scammers because it's easy to spoof caller IDs. It's easy to do a lot of things. It's been heavily regulated in the US and worldwide. Mostly those regulations exclude political messaging. There is still luckily, a lot of regulations around it. It can be generally just annoying because, you get a call, you just hang up, not a problem. But it can be dangerous because of the risk of fraud, especially for people who are maybe less in the know, less technical savvy, etc. So it's important to know what can be done and how we can protect ourselves from it. But first of all, when researching for this LiveWire, I found out a staggering number. In 2020, there were 46 billion robocalls placed inside the United States alone. 46 billion with a B. That is, as the slide says, 140 calls per every single US inhabitant. That's a little bit less than 3 calls per week. But the people living in the Washington, D.C. area have the record of receiving an average of 2 robocalls per day. Alaska and Massachusetts have the least, with probably around 1 per week. Alaska, you can see, I don't know why Massachusetts is so low, but people living in the DC area are just being most likely to call landline, cell, VoIP number. So actually, this brings me to something I forgot to say. You can always ask questions in the chat, and I'll be happy to answer either in line or at the end. So statistics indicate that the calls are equally split between the various media, with a skew towards landline. But I think landlines will be about 40%, 30, and 30. Because voice over IP numbers have so widespread right now that essentially they made their way into the lists of scammings. Great, yeah. Having an IVR is a good way to protect yourself, and in fact, we'll do something similar. Our goal here is, first of all, to display what can be done with SignalWire technology. The application is a demonstration. It's an interesting piece of technology, and I like it very much, and it's been fun to build and play with. But of course, it's part of a broader effort. So how do we stop the bots? There's an important distinction to make. So do we want to know if they are a bot or a robocall, or do we want to stop them when we get them? So verified callers verified calls are part of a broader effort, mostly around the stir-shaken protocol and standard. Stir-shaken is a very interesting effort by an industry itself, led by the FCC, where SignalWire has contributed heavily by sponsoring the development of lib stir-shaken, which is the de facto open source implementation of stir-shaken. And it uses a mechanism similar to how you do similar. So I'll start to stay as little technical as possible. When you see the little lock in your browser, it means you're on a HTTPS website. It means there's a certificate in it that's proving that the website is who they say they are. Stir-shaken allows you to do the same thing with phone calls. So when a phone call comes to your provider, the provider can check the certificates and figure out if the call comes from the rightful owner of that phone number or not. That prevents caller ID spoofing, which is not what we're going to be dealing with today. Spoofing is using a fake caller ID. So not many people know, well, probably people attending LiveWire do, but not many people in the outside world from telephony know that caller IDs are super easy to fake. In fact, the only thing preventing anybody from spoofing a caller ID is just their provider stopping them from doing it. So most providers are good and try to enforce that. So other than that, it's super easy to spoof a caller ID. And anybody here has received a call from someone who was not what they said they are, whether it was the IRS, it was some kind of Washington, D.C. number. I'm from Italy, so I get calls from the police, I get calls from the tax agency, all kind of stuff. Actually, at the end of the month, we will have an entire event about stir-shaken. So there's more about that later. So if you're interested in that, we'll do an entire event more geared towards the open source aspects, which is going to be interesting. And our CEO is going to be there too. But right now, what we're looking at today is how do we stop calls? Stopping calls is in general done through some kind of whitelist or blacklist. So a list of people you want to accept calls from, and or a list of people you want to block calls from. And that's good if you already know who the people calling you are. But if you don't know, how do you tell if it's a robot or it's not a robot? We sat down and figured out a fun way of handling this. And the idea was to use a CAPTCHA. So CAPTCHA is, they call it a macronym. So it's not really an acronym. It's just some kind of fun phrase that describes a completely automated public Turing test to tell computers and humans apart. It's just, I think it's just put together because it's CAPTCHA sounds like caught you or something like that. But everybody has dealt with these in the in the non-voice area on a website. So classic CAPTCHAs are image-based or and involve either recognizing images or repeating text. Although, as we were noticing earlier, many of these actually don't care if you get it right. They measure how long you take to respond and what your movements are when you do it. So it's more often than not, it's okay to get them wrong as long as you behave like a human. So if you click too fast, it won't pass you, not because you had random images, but because it's actually not perceiving you as a human. They're getting pretty sophisticated to the point where the more advanced versions don't have anything to click, anything to write. When you go click on the square that says, yes, I am a human, the JavaScript in the page, the movement of your mouse, and determines that you're a human because, I don't know, you're not moving in a straight line, you're not moving fast enough. A computer will instantly go and click. Your mouse is moving at a normal pace and maybe not in a straight line. So they're getting very, very interesting. So how can we replicate that in voice? It's super simple. As you've seen many times in examples, sometimes when you do call forwarding, a very simple way to sort of protect yourself is just having what's called call screening. So while your caller is waiting and is hearing ringing, on your end, you're something that says, press 1 to accept the call or something like that. Or on the other hand, you can have it on the caller side. So asking them to, I don't know, press 1 to connect to Luca, whatever. Generally speaking, pressing a TTMF is super easy to defeat right now. And we know people who are building on sophisticated ASR systems, such as SignalWire's platform, that use that speech recognition and TMF to actually navigate IVRs automatically. So they try to look for the option that will get them somewhere. So they're getting better. One very simple thing that's actually quite hard to defeat using a stock script. You can do it, but you'd have to do it on purpose. So build something on purpose to defeat this is simply asking for the sum of two numbers. So as we'll hear, we'll ask, hey, caller, what is the result of 1 plus 4? If they get it right, they're probably a human. If they don't get it right, they're likely not a human, or there's someone who can't count, which generally speaking, we don't want to talk to either way, because it's not going to, nothing good is going to come from someone that doesn't know how to do 1 plus 5. So our application will use a simple file-based database to have a whitelist or blacklist to ask people to solve a CAPTCHA. If they fail that, we'll add them to a spammer blacklist. And as a bonus, which is not really part of the application, but it's pretty cool, and I'll show you how it's done, we'll be using Lenny to torture them a little. Of course, from your standpoint, since you're receiving calls and your system is probably paying for some of the traffic, you might not actually want to keep people on the line. But if your traffic costs are low because you're using SignalWire, you can totally just play with people a little. So Lenny is a set of audio files that are sort of ordered that uses generic phrases. And so we'll say something, are you there? Yes. No. They're also spoken in a quite soft Australian accent, which makes it sort of hard to understand everything. And some of them go off on a tirade about his daughter needing something. And as a result, Lenny has been tested and is known to have lured spammers into conversations for an average of 10 minutes, which is absolutely super effective. It's super effective, especially if the callers are not native English speakers, which is very often the case in, let's say, not even spamming, but low end call centers. So it's very, very effective and very fun. Maybe we'll get there later. If the caller knows what the sum of two numbers is, of course the numbers are determined randomly, we will add them to the whitelist. So that tells us they're a human, but doesn't necessarily tell us they're actually people we want to talk to, because what we're determined with asking them for the sum of two numbers is just that they are a human, because they should be. I mean, that's very, very unlikely that a machine managed to navigate that. So that leaves you someone that's calling you to still sell you something, but it's an actual human. So they pass the CAPTCHA. I pick up, and it's, hey, Mr. Luca, we've been trying to call you to reach you about your extended car warranty, which I don't even have because I have an old car, and I probably never had a warranty to begin with. So I don't want to talk to them. So what I do is I can press star 2 times on my DTMF keypad, and the call will be flagged as a spammer, immediately hang up, and added to the same list of the spammer blacklist that we had earlier. Of course, again, here we hang up. We could be sending them to Lenny, etc. The double star is a very advanced feature that Relay has, which allows you to listen for input during a call. It's very effective and also very simple. Of course, actually, just the double star is just an example. So blacklisting spoofs ID, of course, it's not this. It won't be super effective. It could be blacklisting someone legit. But keep in mind, this is not a this is a full-fledged working application. But what we're trying to showcase here is a number of features and a few ideas, more than an actual real. Or an actual real application. Like, you shouldn't probably run this in production. So the Lenny part you can totally take, and pieces of it, like the listening to double star during the call, also is something that you might want to take. But of course, there's other things you should be on each one of our well, I won't say parents, like, depends on how old you are, but if you have parents that are 70 plus, everybody should be running this. Yeah, actually, I've come to the conclusion that for some older people, like 80 plus, etc., it's actually better to just whitelist numbers, and that's it. So that has some other security implications, but still, it is well, on the plus side, too, some people I've I've spoken on the phone with our real life Lennies. Like if you get in a conversation about their children or something, they will keep you there for an hour, which is funny sometimes. Okay, so the application is built on Relay, but what is Relay? So the SignalWire Communication APIs have various forms and various operating modes. One of them is Relay, which is the call communication protocol that powers almost the entirety of SignalWire. Even when you use APIs, it's really talking to Relay under the hood. Relay operates over a standard WebSocket connection, so you don't have to worry about anything special. It has a persistent and asynchronous connection that allows you to do dynamic call manipulation in real time. Everything that goes back and forth in just JSON. So, for example, you can run a large number of calls running in a single process because it's not actually touching the media. It's just getting the events you ask it for, and then you get them back. It provides many, many features. I just listed out a few. Speech recognition, answer machine detection, media manipulation, text-to-speech, messaging, has the ability to send audio to an endpoint you specify for analysis. We did that in a previous LiveWire. And it's a SignalWire innovation more than anything. Again, Relay is what powers the entirety of the platform. It's just that when this application is built on the actual WebSocket standards, there's other ways to do it with HTTPS or other upcoming protocols. Again, integrating Relay is pretty simple, but as we'll see, it runs in its own process. It doesn't require any networking aspects other than, of course, being able to connect to SignalWire in outbound mode. So no open ports, no weird, no networking to handle, and you can put it side by side with your existing infrastructure very easily. It communicates with other applications using tasks, HTTP, and any other mechanism, really. So what needs to be stressed is that Relay Consumer is just a plain process in your chosen language. You want to communicate using HTTP? Great. You want to use a queue like Kafka or AMQP or anything? You can do that too. And SignalWire provides its own mechanism called task that we saw in another webinar, and maybe we'll take a look at in the future too, that allows you to specify that you'd like your consumers to do something. And the something can be anything you've coded. So what you'll do is your, say, web application, your CRM, puts a task on the queue saying, hey, I want someone to send a message to this number with this content. SignalWire will automatically take that task, give it to one of your available consumers, and have only that consumer execute it. Effectively, consumers are horizontally scalable without any kind of change. You can just run multiples, and they will just work. So I think Relay has been very good so far, and it's is the ideal choice, and our customers confirmed that, for adding advanced telecom features to existing infrastructure. We have people using this for a slew of use cases. But let's take a look at what we've been doing here. Demo time. Of course, I chose Sarah Connor as the image for the demo because we're trying to slay bots, right? Great. So I'm going to do something experimental here. I hope it works, which is turn on my look back device. We'll place a call.
Hello, this is Lenny.
Oh, I ended up with Lenny. Hello?
Yes.
Yeah. So as you can hear, Lenny would just go on and on with this kind of leading on questions, like getting attention and then getting more information. So what I was talking to you, I'll just hang up now. While I was talking to you earlier, what happened is that I got the ASR to not hear the correct answer, and as a result, you got Lenny. Now I will need to stop the process for a second and remove the database, because right now I've been flagged as a spammer. If I call again, I will just end up in the spammer list. So as you can see here, we're just storing things in the folder here, and we'll run it again just with Docker. So yeah, it's not liking.
You are probably a robot. That's okay. I am a robot too. I will give you one.
There we go. Well, we got roboted out again. Okay, so let's take a quick look at the code. Once I can get my. So the application consists of a relay consumer and a file-based database that allows you to just save the incoming calls into a list, and then we'll grab it for usage later. Of course, if this ever were a production app, you will have to use a proper database to make it worth your while. There we go. So recordings are public domain. You can use it anytime, and using Docker is the best deployment. There's a link to the application in the slides. And why don't we go take a look at the code, which was probably the more interesting part here. Okay, so everything is contained in an actual single file here, which might make it a little bit of a long read to go about, but it's also a very simple way to organize your code for the, for this demo and for testing in general. Let me close this. Great. So first of all, what is a relay consumer? A relay consumer is the smallest possible amount of code you can write to interact with relay, and it's the process that we were discussing earlier to help organize your code better. You see, we have include here that just brings in the relevant stuff we need to actually work. And then the Lenny function. Lenny function is actually more fun to look at than it's actually useful, but it's worth taking a look. So the as you can see, the Lenny functions will just grab the URL. We have a Lenny config that has the files in it, and it will either try and get attention. So it will play one of the attention getters, such as "Hello, this is Lenny," or "What about my daughter?" and stuff like that. Or it will play prompts and responses. Getting responses is something like yes, 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 or yeah, can you help me, or something like that. That keeps the conversation going, and it's super fun to hear working. More importantly, though, what I wanted to show you is so we didn't complete the call earlier because of the audio issues, but if the call actually goes through, it will dial me. The dialing is done through a connect call from the relay API. And then when it dials out, the important thing that happens here is that we start a detector and look for updates. Every time we get an update, we call this digit parser. That's an object that has been set on the call, so we can see what's going on. So this other example is actually interesting because you can not only do the double star, like it would have been easier if we didn't want to show you, it would have been easier. But we do here, we collect the strings, and then every time a DTMF is pressed, we go check if it matches something. For example, you go after this double star block, you could add another block that says if the user presses 1 2 times, activate something else, like bring a third person into the call. If 1 or 2 presses 2 2, play audio into the call with the account ID of the person. Say you're on a customer service system and you want to play some data for the user, 2 2 automatically plays their reservation number, so it's played back over and over, things like that. So you could be doing anything here. What we do is just the double hang up, which is the interesting part. What else? Then we wait for the call to end, and that's it. So handling the call, which is the incoming call, is some of the somewhat interesting part. So we run in a general screen mode, and then we ask for the CAPTCHA. CAPTCHA is super easy, actually. It's just we get something from the configuration. We'll look at the configuration in just a second. We activate some SignalWire secret sauce here by using the denoiser. The denoiser is a very advanced feature that we recently deployed that allows your calls to be crystal clear. And it's very useful when you're doing speech recognition. Okay, so we build the answer string. So people could be answering the two numbers are between 1 and 9. So the answers are 1 and 10, I think. So the answers are anywhere between 2 and 20. And we then ask for the actual question. Actual question is just getting two random numbers. Then we say, what is 5 plus 4? And then we allow people to have a few tries. So if they run out of tries, they're a scammer. Otherwise, we will ask them and tell them how many more tries they have. If something fails, of course, we'll bail out saying something didn't work. And that's it, really. It's an actually quite simple application. On the initialization step, we initialize this database, which is just a storage item. This is called node persist. It's a JavaScript. So denoiser is not really specific. There's a label equivalent that's going to be released soon enough. It's actually ready. So there will be one in the XML version too. It's actually ready to go. So it'll be out very, very shortly. We're just waiting on documentation, actually. And then the meat of the process, the consumer we create. A consumer, again, is the simplest possible block of code you can use with Relay, and this is the one I'm most recommended. It will register to a context. A context is a group of phone numbers that will receive calls and forward them to this particular group of Relay consumers, or only one if you have one, of course. And on an incoming call, we just use the code we set up earlier to actually grab the user and see if they're a bot or not. We set up storage, a few other things, and that's it, really. The more interesting thing here is that the entire application is configured to this JSON file that allows you to set all the introduction messages, allows you to set if you want to use Lenny or not. That's what I was saying earlier. Lenny is funny, and it will record calls and give you some fun at the expense of people trying to spam you, but it's not really cost effective. So maybe you want to turn it off. So there's a way. Number map is how you map your incoming numbers on SignalWire to your own phone number. And the Lenny configuration is really just a group of files that, I think these are actually public domain. There's not really coming from anywhere in particular. Lenny is pretty known. There's a few others, but the original is the most funny. And there's like 16 files, and that's all you need to really terrify scammers. So it's very, very fun. That's pretty much it. So the application is configured through this JSON file that contains everything you need to configure it, and then you run it through this JavaScript consumer using your. You can either use Docker or run it locally. That's it. That is the main. That's the main part here. So take a look at the code. Take a look at how it works. Yes, you can. Well, those Lenny files aren't guaranteed to stay there for a long time, but if you want to download them, go ahead. They are public domain, so even if they're not going to be there for a long time, you can use them right now if you like. Okay, what else? I think we're almost done here. And features we saw in motion are. Oh, I'm trying to share my screen again. Yeah, it's better if you download them. I think they'll be there for a long while, but we never know. Might move stuff around. So, what features did we use in the application? We went through. So we used PSTN integration, test speech and speech recognition, detecting DTMF, and we integrated an external service. It's just a quick list of things we can do on Relay, and you can do on the SignalWire platform, integrating with your own app. So that's pretty much it. Again, there's a lot to see. There's a lot of code to look at. I'm happy to help. I'm happy to answer questions. And but first of all, it's easy to get started. Go take a look at the Relay Docker images that I'll link on the bottom. You can use Relay in parallel with your current infrastructure. And there's a bunch of starters. I've wrote a new Relay Getting Started guide just last week. There's plenty to take a look at. No, the DTMF detection distinguishes between inbound and outbound because the detector is only started on the answering leg. So the one that's supposed to be you trying to prevent spamming. So no, if they hit double star, they don't blacklist themselves. So it could be a cool feature. Like if you press double star and there's no reason, we probably don't want to talk to you. So you're right. We should probably add that. QA. Oh, using SignalWire for SIP and VoIP on your desktop? Yeah, that's a good starting point. There's many other things you can do. If there's any drop packets are a huge problem, really? Well, can you reach out to support later and we can take a look together? Latency should be quite good. We never had any particular problems, but I'm happy to help. We can certainly take a look and see what the instance what the problem would actually be. The audio path on this demo is my phone is calling a PSTN number that goes to SignalWire directly. The audio stays on the SignalWire platform, and only the JSON controlling the call comes to the consumer that is running on my computer. So effectively, the only audio path here is between my computer and SignalWire servers. There's no audio leaving that path ever. Great. So if there are any other questions, or of course, if any questions come to mind after okay, let's wrap this up. Yeah, no, the relay consumer doesn't need to be close to SignalWire. It doesn't really matter because it's only JSON. It's gonna be pretty fast no matter what. Of course, if you have 2 seconds delay because of your network conditions, you're gonna feel that because when call got picked up, it will take 2 seconds to actually react. But other than that, the relay consumer itself can run anywhere. Doesn't really need to be close to the people placing the calls, for example. Doesn't really need, but it's of course, this is a demo, so I'm running it to my, you can call a known SignalWire number, in which case the call will just be billed as normal outbound traffic. And yeah, totally, you can just put in fact, we have many people, many customers, including a few large ones, getting SignalWire numbers and building call screening and call forwarding systems for systems that they actually already have. So it's a common use case. Good. So if there are any other questions, again, custom music in IVR. Okay. Yeah, there will be a link for a presentation for sure. So don't worry about that. And I'm very happy to help. Again, just reach out to me. My email is just luca@signalwire.com. So I'm really everywhere. And I'll drop my email into the chat box. If writing the name properly will help. Email me anytime. I'm always here, happy to help me and my customer success team. Cool. So custom music in IVR is super simple. Just play whatever you like. SignalWire will play anything you give it in the form of an MP3 or a WAV file that's reachable through the public internet, or a signed URL on S3 in case you want to do something that's we do support signed URLs too. And well, thank you. There was thank you. Yeah, so our pops are expanding geographically, so I'm happy to take a look at what you have going on there and see what we can do together. Please reach out to me or support after we'll take a look. Well, thank you. There's we have another event on April 21st, and we'll talk about building an automated reminder app on Relay that will call someone, remind them an appointment, and help them change the appointment. There's going to be a display of advanced ASR and integration with the calendar system, so we can actually take reservations for real. Thank you very much for joining us today. It's been a pleasure, and I hope you liked the speech. And well, I'll see you on April 21st, hopefully. Thank you so much.